Hey y'all. Okay, so we are going to do multiplying and dividing real numbers. These are problems from 9.6. Okay, so just like whenever we were adding and subtracting real numbers, there wasn't like rules per se that we followed. We basically had these two things that I believe is helpful to understand and to use. We have the same type of things with multiplying and dividing real numbers. So they are, if the signs are the same, let's do equal positive. So same equals positive. And then we have if the signs are different, we get negative. Okay, so again, these aren't like rules, but this is hopefully a way that's going to make what we're doing just kind of make a little bit more sense. Okay, it let me do it earlier. It won't let me do it now. Okay, I'm just going to scoot up, y'all. Let's say we have an example like this. It wants us to multiply numbers. This is exactly how to look in your homework. We have parenthesis, -4, close parenthesis, multiplied to parenthesis 5 parenthesis. I kind of think it's a little overusage of parentheses, but this is how the homework looks. I want to make sure that when you see it on your homework, you can solve it, okay? So this is what I recommend you do. This is what I do. Once these problems start getting a little bit more involved, so far, all of this has been, pretty much all of exam one, has just kind of been a buildup. We've been looking at little bitty pieces of a larger problem, and then later it'll be a big problem. We actually do an example of that in 9.6. But when we have these bigger problems, my hope is that you can look at them as a bunch of little problems that you solve first. So, okay, this is what you do. You look at the numbers, just the coefficients. That's the 4 and the 5. You multiply them together. If you do 4 times 5, you get 20. Now I look at their signs. I have a -4 and I have a +5. So that's that first line up there. Nope, that's the second line. Signs are different. So that means that my product, when I do my multiplication, what I get is a negative term. Okay, so let me show you an example going with the other one. Say we have a -2 times a -15. Just look at your numbers. Use your calculator. 2 times 15 is 30. Those signs are the same, so you get a positive. That makes sense? Okay, so I'd like to point out a special note here that 0 is not a, see, when I don't even mean to, it doesn't. 0 is not a negative or positive term. 0 is just 0. Okay, it's just 0. So let's just say, for an example, they were to give you something similar to problem 1 and problem 2. Say they give you a -4 times a 0. Okay, I remember her saying, do the numbers, look at the signs. They want to try to confuse you like this because you want to do 4 times 0. What do we get? I get 0. And then, oh, signs are different. It's negative. That is the correct thing to do with every other number except for 0, okay? This right here is very important. 0 is neither negative nor positive. It is just 0. So even if one sign's negative and one sign's positive, your answer is still just 0, okay? Let's see if we can do this one. I'd like to do this example because there will probably be 1 or 2 in the homework. It's using the same train of thought, but, oh, yay, let me do it. It's using the same train of thought, but what we're actually going to look at is a couple of fractions, and they usually overuse the parentheses, y'all, okay? So let's go ahead and do that. Say we have, in parentheses, 2 over, oh, no, it wasn't a 2. That's why I got confused. Oh, okay. Let's do 3 over 4 times. So you could indicate that with our multiplication symbol, or just like example 1 and 2, it could just be 2 sets of parentheses touching each other. Those also mean multiplication, okay? And then, actually, I think that's how they do it in the homework in this section. So let's go ahead and do that. Open another set of parentheses. And then we're going to multiply to that 5 over 7. Close your parentheses. Let's make the 5 over 7 fraction negative. Okay? So all I need to recognize here is that it's multiplication and that there's fractions and that we've done this before. And what I do is I multiply the top and then I multiply the bottom. And then I'm going to look and see what I need to do because of their signs. So if I do the top, if I do 3 times 5, I get 15. 3 times 5, I get 15 over. Now we're going to look at the bottom, the denominator, and we do 4 times 7. 4 times 7 is 28. And now I look. Signs are different, so my answer is negative. Does that make sense? If I have 2 fractions that are multiplying each other and they're both negative, well, that would fall under this category. They would both be the same sign, so it would be positive. Does that make sense? Okay. Okay, so I'm going to turn this off, make sure it uploads, and then I'm going to do, no. I said dividing on here. Let's go ahead and do it, y'all. Let's go ahead and do it. I'm just hoping that it records. Dividing. Go back to black. Now let's do some dividing examples. Same train of thought, okay? Same is positive, different is negative. So if they have me do a negative 15 over 5. Okay, so this would be, the answer to this is going to be a quotient. So previously, the answers that I got, the negative 20 and the 30, those were products. This is going to be my quotient. So it may even say find the quotient. Okay, so that fraction bar is actually read as divided by. So this is saying negative 15 divided by 5. You need to use your calculator, that's fine. I'm going to look at the numbers first. I do 15 divided by 5 is 3. Signs are different, so it's negative. Okay, say we have a negative 14 divided by negative 2. Negative 2. Okay, I'm going to look at the coefficients first, the numbers. 14 divided by 2 is 7. Signs are the same, so it's positive. Okay, so just like I had before, there is a little note with the division part of this homework. And my note is 0 can be divided by anything. 0 can be divided by anything, period. Quotient. That's basically a fancy word for the answer to a division problem. The quotient will always be 0. In other words, answer always equals 0, okay? So that's literally 0 divided by anything will always be 0. Okay, so let's do a quick example here of dividing fractions. I'm actually going to use this exact same problem right here. 3 over 4 divided by 5 over 7. Okay, but we know, first foremost, you cannot divide fractions. You have to keep, change, flip. So what we do is we keep the first fraction the same, change to multiplication, flip the second fraction. Now we multiply straight across. 3, I'm going to highlight them as I say them, y'all. 3 times 7 is 21 over 4 times 5 is 20. Now let's look. I have a positive 3/4 and a negative 7/5. Signs are different, so it's negative. Okay, y'all. So I'm going to go ahead and get this uploaded, and then I actually have a hard example to do that's like towards the end of 9.6. So I will do that shortly. Thanks. Bye.